C is considered to be a base to start programming. Being a successor of B, C was developed by Dennis Ritchie and is a general-purpose structured programming language. Here, structured means that it follows a certain way of execution to improve clarity, quality, and development time of a program. There are various tools for various platforms to use C. Here we are going to use Online GTB. It gives us the option to program in various languages and comes with a handy toolbar. Program is written here and get our output in this console. In C, source file have an extension of .c, whereas header files have an extension of .h. There are even other files like .i, .obj, etc., but are of no concern to us. Source files are the files that store our program, and headers contain pre-written code for our use. A preprocessor is a program that formats the code before compiling, and these are its commands. In this video, we are gonna use only #include to include header files. While declaring variables, the type of data to be stored needs to be given. Data can be primarily of four types: characters, integers, floats, and voids. Characters store single letters and can be alphanumeric or symbolic. Integers store numbers and floats store numbers with decimal places. Voids do not store any data. Signed variables store positive and negative data, while unsigned store only positive. Character set is the set of characters that are allowed to be used while programming. In C, we can use uppercase and lowercase alphabets, numbers, and some symbols. Tokens are small division of an instruction used by the compiler to understand the code. Tokens contain operators, special symbols, strings, constants, identifiers, and keywords. Every language has its own way to understand code. In C, a semicolon marks the end of line. Also, double slashes declare a single line comment, while the text between /* and / declares a multi-line comment. A comment is the text that is not executed and is ignored by the compiler. Here, ++ stands for increment, -— for decrement, double ampersand is a logical AND, double vertical lines is logical OR, and the exclamatory mark is for NOT. Now coming on to data input and output using stdio.h, we mainly use 6 commands: printf, scanf, getchar, putchar, gets, and puts. Let's see a simple code where we have included stdio.h, a header file, and main function as void. In its body, we have an example of single and multi-line comment, followed by an integer variable I with printf and scanf statements. Send gets an integer, while &I gives the address of I variable, and \n provides a new line. The program runs successfully, giving us the value of 10 as we have entered it. Decision making. When we need to run a block of code only at certain conditions, we tend to use statements like the if, switch, and goto, while also opting for conditional operators in some cases. The if statement has 4 types: simple if else, nested if else, and else if. The if statement runs a block of code when a condition is matched. If the condition is not matched, the else block will execute. If there are several conditions, we can use else if, and nested if means an if inside another if. Let's see a simple if-else example. Here, 2 variables x and y are declared as integers and initialized to 15 and 18. Now, if x is greater than y, x is greater than y will be displayed as it is in the if body. Otherwise, y is greater than x will be displayed as it is in the else body, and the output is y is greater than x. Coming to the switch statements, these are used when several conditions for the same expression are to be checked. The code blocks followed the case statements after a colon. Moving on to an example. This example or switch case declares a variable x as integer and gets its value from the user to further pass it to the switch block, where in case 1 choice is 1 will be displayed, in case 2 choice is 2 will be displayed, and in case 3 choice is 3 will be displayed, whereas the default case acts as a else statement and break statement is used to exit the switch block. Further, return 0 returns a value of 0 to the calling function, and here is our output as we enter 2. Looping. As from the name, it means iterating or repeating a block of code until a condition to stop is met. There are 3 types of loops, namely while loop, do while loop, and the for loop. The while loop is the simplest form of loop. Here, a counter variable needs to be initialized and then checked for a condition. The block of code runs while incrementing or decrementing the value of our counter. This simple while example has an integer x initialized to 1, which when less than or equal to 10 executes the while block, where the value of x is displayed with tab spaces and incremented with x++, hence giving us the following output with numbers displayed from 1 to 10. Sometimes you need to check for a condition after the block has been executed. For such cases, we use do while loops. These are similar to while loop, just having the exception of while statement at the loop block's exit. Let's see a code. This do while code has 2 integers a and I, where the value of a is taken from the user while I is initialized to 1. Further, the do block executes printing a into I with tab spaces and incrementing I. The while statement checks whether I is less than or equal to 10 and controls the flow of loop, giving us the following output as we enter 4. For loop is the favorite loop of most programmers. Here initialization, condition check, and incrementation or decrementation of counter is done in the same line as in for's round brackets. For the other part, it is same as while loop. Moving further, the for example has a variable x as integer, which is initialized to 1 and checked for less than or equal to 10 and incremented in for brackets, which is then used to display 1 to 10 with tab spaces in for body using printf, giving us the following output from 1 to 10. You must have seen in the previous examples that the break statement was used to jump out of a switch statement or a loop. Similarly, the container statement can be used to return to the loop start for next iteration. A variable can store only a single value, hence we use arrays to store multiple values with the same name. These values are called elements and are accessed by a counter or index. Array declaration is same as of the variable, just having square brackets with array size in it. In short, arrays are like a matrix. We can also have multi-dimensional arrays by adding more square brackets and size in front of the variable name. Switching to an example. Here we have an integer I and an integer array ARR, which is initialized with 2, 3 and 4. Its value is then displayed using for loop and tab spaces as seen over here. A string is a continuous set of characters. They are defined as character arrays and can be operated using the string.h header file. These are some commands from string.h. Moving on to storage classes, we can define variables with 4 types, namely automatic, external or global, static and register. Automatic variables are defined by using the auto keyword and are local to their function block. On the other hand, external variables are declared using the external keyword or are directly declared out of any function. Static variables being local to a function block differ from auto for initial value. They stay in memory as long as the program executes, whereas autos get removed as soon as the function is over. Sometimes a variable is frequently used, hence they can be declared as register to store them on a CPU register. Since CPU registers are mostly busy, register variables don't always stay on CPU register. Further, in this example of variable types, we have 5 integer variables, with G being a global variable, N as a normal declaration, A of auto type, S of static type, and R of register type, and hence we have their values as displayed. Getting to functions, they can be of two types, library and user-defined. Library functions are those that we get by default from the headers, whereas user-defined functions need to be defined by us as per our use. Every function needs to be given a return type. This is the type of data we are gonna return to the calling statement. The calling statement can pass data to a function using arguments. Moving further, this example has a function named multiply, which has two arguments as int a and int b. The values of integers I and j are taken from the user and are used to call the multiply function. The multiply function multiplies these values and returns it, which is then stored in the results integer variable, hence giving us the following output as we enter 2 and 3. Structures defined by the struct keyword are used to define a set of variables. These can then be used to declare structure object. For example, here we have a structure named student, character array as name, an integer as age, again a character array as branch, and a character variable as gender. Then in the main function s1 is declared with this structure, and a value of 19 is stored in its age variable. Then a string of my name is copied to its name array and then is displayed as shown. Sometimes the structure name can be too long or override another. Hence, for such cases we use typedef. Like here we have used typedef with structure student to give it a short name stu. This structure contains a character array name and a integer variable age. Then in main body, s1 is defined with student structure and its field values are taken from the user to further display it in the console. Unions are similar to structures with an exception of having shared memory. For example, here a union is named item and has three variables as a, b and ch as types int, float and char respectively. In main body, union item is used to declare it. Then its fields are initialized and printed on separate lines, giving us the following output. Now you can see that the values of a and b are corrupted while the value of c is as it is. This is because unions have shared memory and the last declaration will override the previous one. Further, pointers are variables that store the address of another variable. Here ampersand denotes address of, whereas asterisk denotes at address. Like for example, here we have an integer a initialized to 10, then a pointer ptr which stores the address of a. You can see that the value of ptr is equal to the address of a. Files have an important role in programming. This topic can get a bit complex, so do pause the video if you don't understand anything or write down in the comments below. These are some functions related to file operations. Moving further, these are various ways to access a file. These ways or modes define reading and writing to a file. For example, here we have a structure emp used for e and file pointers p and q.
which then are used to open 1.txt in append and read mode. Values of e.name and e.age are taken from the user and returned to the file 1.txt. Further, this written data is accessed in do loop while not end of file. Hence, we can see that as I entered my name and age, it is stored in 1.txt.
Sometimes we don't know how much memory is to be allocated while writing the code. Hence, we use commands such as malloc and calloc to define memory at runtime. Let's understand by an example.
Here we have four integers n, I, ptr and sum, where ptr is a pointer and sum is initialized to 0. Value of n is taken from the user, which stores the number of elements. Then malloc function is used to allocate some memory and store its address in ptr. If the memory is not allocated, an error will be displayed and the program will exit with a return of 0. If the memory is allocated, value for each element will be taken from the user, hence giving us the following output as we enter 3 as element number and then 1, 2 and 3 as elements.
Now, while executing a program, we can give arguments to the main function. For example,
here int argc stores the number of arguments, while character array pointer argv stores the arguments. These arguments then can be retrieved and used for various purposes, like here they are displayed in the console.
thanks for watching. Do like, subscribe and share this video and press the bell icon. See you in the next one.